Welcome to part 2 of our video series about the graphical programming system test.con 6 Studio. In part 1 I have already programmed a small application for the real-time kernel of the Q.station and uploaded the application into the real-time kernel. In this part I would like to introduce you to application connectors. Application connectors are basically the same as inputs and outputs of an application. If these inputs and outputs are placed on real-time application, the user space application is able to access certain data points, like calculated values of the real-time application. It is also possible to define parameters from the user space. On the screen you can see the application, which I have already loaded into the Q.station in part 1 of the video series. I would like to extend this application by application connectors, so the user space application can access these data points later on. Therefore, I will now change into edit mode. Application connectors are implemented over special variables. These variables, on the other hand, are implemented over block attributes and the block diagram. In part 1 we have already connected the I/O variables to this min-max block over the block attribute. I could now connect the application connectors to this output of the min-max block. As you can see, a block has already been assigned here. That is why I will use a special block, an auxiliary block of the type pin. This pin block is used to create a breakpoint to block attributes. This block now demands me to choose a data type. If I'm not sure about which data type to choose, I can just cancel the dialog. Now the pin block is depicted gray. That means that no data type has been assigned yet. If I now connect this pin block with the output min-max, the data type adjusts to the data type of the output. In this case it is float. We are docking an attribute to the output of the pin block. Therefore I will choose the command assign variable. Subsequently, the data point management window opens. I have already shown you that in video part 1. The data point management is divided into 3 sections: project variable, Q.station IPDT, and app connectors. In the section project variable, you can assign your own variables, which you can use for internal communication in the project. The section Q.station IPDT contains the I/O variables, and in the folder app connectors I can now see my application connectors. You might have noticed that the variable pincette, which is tweezers, is not shown in the folder Q.station IPDT. There is a simple reason for that. What we have here is an output variable, which is a write variable. As the variable tweezers only has reading rights, this variable is not shown because I would write this variable with this command. I will now go to the section app connectors and to the subsection RT app. In this section I will now assign my application connector for the real-time application. To do so I will select new data point and assign the name pincette max. I will assign a variable for min at this point too. I will type in pincette min here for now, and I will select pincette max, as I would like to assign this variable now. I will copy this combination of the pin block and the variable value with the keyboard commands Ctrl+C and Ctrl+V. Then I will connect this variable with the min output of the min-max block and assign the application connector to the block attribute, meaning the pincette min. Next, I will assign an application connector at the reset input to be able to reset the min-max block. I will click on Assign Variable to do so. You can see that there is no variable in the section RT app. That is because I have selected the filter bit-byte as data type. If I select all here, you can see the min-max tweezer values. I will now create a new variable. I will call that one reset min-max. The data type bit-byte has already been specified. You can see up here the data type df for the min and max value of the tweezers. For the reset block, we have the data type m for flag, or in this case bit-byte. I will now upload this program into the real-time kernel of the Q.station. To do so, I will change into run mode and select real-time kernel of the Q.station. Nothing has changed about the result of the application. The minimum and maximum value is still being calculated. I am now able to reset the block and read the min-max values of the tweezers in the user space application, which I will program in part 3 of the video series. The measured value of the tweezers from the section IO variables are offered in the user space application as well. I hope I could explain and show you how to assign application connectors more clearly. In part 3 of the video series, we will write a user space application. I will show you how you can access the regarding variables. Thank you very much for your attention, and I hope I will welcome you again in my next video.